Now exercise 7.2, question number 18. Your question number 18 is this is e to the power of tan inverse x by 1 plus x square dx. Here you can see that again by the help of substitution this is possible, and see, you know that differentiation of tan inverse x is 1 by 1 plus x square. So this makes it easy to solve it. So let tan inverse x is equal to t. When you differentiate tan inverse x, you are going to get 1 by 1 plus x square dx, that is equal to dt. Now here you see this value becomes to dt, and e to the power of t dt. So what do you find? That you find that this big question, it has been reduced to a small question, and this integration of e to the power of t dt is available with us. So your answer comes out to be e to the power of t plus c. Now putting the value of t, that is tan inverse x plus c. So this is your answer. So this is how substitution help us in solving the problems. Now my next question is, this is 19, question number 19. This is e to the power of 2x minus 1 by e to the power of 2x plus 1 dx. So how you are going to solve it? Now here there is a problem. The problem here arises here that if you suppose the denominator, you are not going to get the numerator. So a modification has been done here. The modification is that e to the power of x minus e to the power of minus x, e to the power of x plus e to the power of minus x dx. This can be written as this. So let me solve it for you. You see that e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. So e to the power of x minus 1 by e to the power of x, again e to the power of x plus 1 by e to the power of x. If you take the LCM here, it will be e to the power of x, and this will comes out to be e to the power of 2x minus 1, and here LCM will be e to the power of x. This is e to the power of x, LCM, and here it will be e to the power of 2x minus 1. So here you find that e to the power of x cancels out and you get the question. So here a slight modification has to be done, and now by doing this slight modification, it is now possible to integrate the question. So if you suppose this, let e to the power of x plus e to the power of minus x is equal to t. If you suppose this, now when you going to differentiate it, you will get e to the power of x minus e to the power of minus x dx is equal to dt. So here you see that you have got the numerator, and now it becomes easy to solve it. So instead of this, I am going to put the value of dt, and by this is t. So this comes out to be log t plus c, and the value of t, that is log e to the power of x plus e to the power of minus x plus c. So you must remember some shortcuts, that if the differentiation of denominator is present in the numerator, then the answer will be the log of the denominator. So this is your answer, and this is question number 19. Now I am going to question number 20. The question number 20, in question number 20, that is in question number 20, here you see it is integration, it is e to the power of 2x minus e to the power of minus 2x by e to the power of 2x plus e to the power of minus 2x dx. Here no modification has to be done to the question, because you can easily see that if I suppose the denominator, I am going to get the numerator. So let e to the power of 2x plus e to the power of minus 2x is equal to t. Now when I differentiate it, the constant comes here to e to the power of 2x, and this is minus 2 e to the power of minus 2x dx dt. So in differentiation, the constants gets multiplied, and integration, the constants get divided. This shortcuts you have to remember. In differentiation, the constant gets multiplied, and in integration, the constant gets divided. So here you see that I remove the 2 because there is no 2. 2 to the power of 2x minus e to the power of minus 2x dx is equal to dt. So here e to the power of 2x minus e to the power of minus 2x dx is equal to dt by 2. So instead of this, I am going to put the value of dt by 2, and this is t. So what are you going to get? See, you are going to get that is 1 by 2 dt by t. So this comes out to be 1 by 2 log t plus c, and this is equal to 1 by 2 log value of t is here. This is e to the power of 2x plus e to the power of minus 2x plus c. This is your answer. This is your answer. So here you see that how these are being substitutions helps us to solve the problems in integration. How this they help you. Now my next question is. Next question, it is 10 square, that is 21, that is 10 square 2x minus 3 integration this. Now you have found in the basic formulas of integration that there is no formula for integration of 10 square x. There is no formula for 10 square x, but there is a formula for sec square x. Now I can convert this 10 square x to sec square x. I can convert it easily because we know this formula, sec square x minus 10 square x, that is equal to 1. So I can easily convert this 10 square x to sec square x. Sec square x minus 1 is equal to 10 square x. So here you see that I can easily convert this from 10 to sec, because there is no integration of 10 square x, and we know that there is an integration of for sec square x. So I have converted this 10 square x to sec square x, and this question now turns up to sec square x is here 2x minus 3 minus 1 dx. Your 10 square is now converted to sec square x. Now here again you see that sec square 2x minus 3 dx minus dx. I am not going to let this 2x minus 3 is equal to 2t. I am not going to suppose this because the question becomes, the solving becomes lengthy. I will take a shortcut, that is, we know that the integration of sec square x is 10x. We know that the integration of sec square x is 10x because differentiation of 10x is sec square x. We know that. So here this comes out to be 10 2x minus 3, and this constant, it gets divided here, minus x plus c, which I have told you earlier that in differentiation the constant gets multiplied, and in integration the constant gets divided. Constant means the constant which is attached to the variable. Now the constant which is attached to the variable, the constant which is attached to the variable is In differentiation it gets multiplied, whereas in integration it gets divided. So here you see that in this question I have not used the any method of substitution, because here I have to do the substitution. If I am going to do the substitution, the questions become a little bit lengthy. I have made a shortcut. You must remember that in differentiation the constant which is multiplied by the variable, it gets multiplied in your answer, but in integration the constant which is multiplied by variable gets divided. So here I have taken that shortcut and I have solved this problem. Now I am going to next question. To your next question, that is sec square integration 22 sec square x 6 square 7 minus 4x by dx into dx. Here again I am not going to take the help of substitution, because I have to in substitution I have to take let 7 minus 4x means if I am going to use the theory of substitution, then let 7 minus 4x is equal to t. Now differentiating both sides, what we are going to get, that is minus 4 dx is equal to dt. So dx is equal to dt by minus 4. So here the question turns out to be, that is minus 1 by 4, and sec square that is sec square t dt. So here we have got the integration of sec square t, and this is equal to minus 1 by 4, that is 10 10t plus c. So that is equal to minus 1 by 4 10, that means 10, what is the value of t, that is 7 minus 4x plus c. This is by the help of substitution, this is the procedure. But I have already told you a shortcut. That is, the shortcut is, you know that in differentiation the variable which is multiplied with the constant which is multiplied with the variable, in differentiation it gets multiplied, but whereas in integration it gets divided. So simply I am going to write, that is 7 minus 4x divided by minus 4 plus c. So this is your one line answer. Now my next question is, that is 23, that is 23, and it is integration of sine inverse x by root over 1 minus x squared dx. So again this question, here I am going to apply the method of substitution. That is, I am going to take sine inverse x as t, because we know that the differentiation of sine inverse x is 1 by root over 1 minus x square. So let sine inverse x is equal to t, and differentiation of sine inverse x, it is dx by root over 1 minus x square, that is dt. So here you can see clearly that this value comes out to be dt, and sine inverse x, that is t. So t dt, the whole question has been converted into t dt, and it has become easy to solve it because we know this formula, and this comes out to be t square by 2 plus c. What is the value of t? That is equal to sine inverse, this is sine inverse x the whole square by 2 plus c. So this is your answer. So this is your answer. Now I am going to a next question. Your next question here, this is also an easy question because the picture is quite clear to solve it. Here this is also an easy question because the picture is quite clear here. Question number 24, you see that 2 cos x minus 3 sin x by that is 6 cos x plus 4 sin x dx. This is your question. So here you find that everything is clear here. You see that you never go to the constant, you always go to the functions. Here you see that whatever 6, 4 doesn't matter, but here it can be adjusted. But if you take the denominator, differentiation of cos x is minus sin x, here minus sin x is available, and differentiation of sin x is cos x, this is available. So here I can take one thing I can, so first of all, before proceeding, let me take a common here. So this will become 2 is the common, so 1 by 2, it is 2 cos x minus 3 sin x by, this is 3 cos x minus plus 2 sin x, plus 2 sin x, 2 common, 3 and 2. So now I am going to suppose this denominator. If let 3 cos x plus 2 sin x is equal to t. So when you are going to differentiate it, what do we get? When you differentiate it, here it will be minus 3 sin x, and this will be plus 2 cos x, and dx is equal to dt. So here you see that 2 cos x and minus 3 sin x, it is available in the numerator. So the whole question gets converted into like this. That is equal to, converted into dt by 1 by 2 dt by and t. So dt by t, so the answer is clear. It will be 1 by 2 log t plus c. So this will be 1 by 2 log, value of t is this one, that is 3 cos x plus 2 sin x and plus c is equal, this is your answer. So this is how we can solve it. Now I am going to question number 25. Question number 25, here question number 25 is this 25, that is integration of dx by cos square x, cos square x 1 minus cos, this is cos square x, cos square x 1 minus 10x the whole square. So here you see that, first of all you take some heat and trial method. You know that if I differentiate 10x, we are going to get 6 square x. So, but cos square is square x is present. Since cos square x is present, so 6 square is available. How? See, the question becomes, this is 6 square x, because 6 square is the inverse of cos square x, and now 1 minus 10x the whole square. So here you see, now the integration is very easy for you. You take, let 1 minus 10x is equal to t. Now when you differentiate it, you are going to get minus 6 square x dx, that is equal to dt, that is 6 square x dx, that is equal to minus dt. Now here you are going to place the values of here, that is 6 square x minus dt, and 1 minus, that is t square. Now the integration has become easy for you. You can easily do it, that is minus t to the power of minus 2 dt, and this is equal to this is equal to t to the power of minus 2 plus 1 by minus 2 plus 1. So this will be equal to minus t to the power of minus 1 by minus 1. This becomes positive. So 1 by t plus c. So what is t? That is equal to 1 by 1 plus, this is 1 by, value of t is equal to 1 by 1 minus 10x plus c. So this is your answer. So here you find that this is your answer.